Okay, folks, so for today we're just going to be doing a little bit of review on the difference between a metal and a non-metal and the type of compounds, that's when you take two different types of elements that are formed when you put together a metal and a non-metal. We're also going to do our first little introduction into bonding, what types of bonds are formed when you put together a metal and a non-metal or two non-metals. Okay, so let's jump right into it. Some physical properties of metals. The first one is that they're all very hard, right? And if you've ever, hit a metal, you know that they're very hard. Although when we say hard in science, we're not actually talking about hitting it. We're talking about scratching it. So metals are very difficult to scratch. Okay, second physical property, they're malleable and ductile. Remember, this means that they're easy to shape, right? So you can take a metal and you can shape it into pretty much any shape that you want, right? Think about copper, right? You could shape it into a sheet. You could shape it into a wire. Okay, so then our next physical property is that almost all metals are good conductors of heat and electricity, right? If you think about the wires in your electronics, they're always made of metal. Um, if you think about like heating up a pan on the stove, you don't want to touch the pan because the pan is made of metal and it gets very, very hot. So they're good conductors of heat and electricity. They're solids at room temperature. So this is true for every single metal except for mercury. Mercury is a liquid, but every other metal at room temperature they are a solid. They're Yeah, you never really see metals as liquids or gases. Okay, and then last up is that metals have very high melting and boiling points. And so that means that kind of goes right along with the previous one. It takes a lot of energy to get a metal to melt, and it takes even more energy to get a metal to boil into the atmosphere. Um, and so that's why most metals are usually solids at room temperature. Okay, and so then we kind of know this from our last lesson, but metals are found on the bottom left of the periodic table. So all of these elements over here are metals. Now, here we have a lithium atom. And if you remember from our ions, that this lithium atom, it's only got one valence electron, and it's going to lose that valence electron. When it does that, it's going to have an empty valence shell. And because now it has more protons, 1, 2, 3 protons, than electrons, 1, 2, and because protons have a positive charge, that lets us know that metals form positive ions. Okay, so now let's go on and talk about nonmetals. So here we have some nonmetals on this side. So some physical properties, they're soft, right? So sort of the opposite of metals. They're usually very easy to scratch. They're brittle. That means that they break easy. Break into little pieces. You can't like shape them like you can with metals. If you try and do it, instead of bending, they'll just break. They're poor conductors of heat and electricity, right? So that means, you wouldn't want to build a wire out of a non-metal. Wouldn't be good. Okay, they can be a solid, a liquid, or a gas at room temperature. And so here we can see examples of all of that. And we've got liquid bromine, we've got solid phosphorus and sulfur, and then we have gaseous chlorine right here. So you can see lots of different examples of nonmetals. They can be really any state at room temperature. But in general, they have lower melting and boiling points than metals do. And so it's much easier to get them into the liquid or gas phase you just have to heat them up a little bit, and then they'll turn into a liquid or a gas. Okay. And so remember that metals were found on the bottom left, so that means that nonmetals are found on the upper right or top right. And so these are the nonmetals over here, and then also hydrogen over here. So if you're looking for nonmetals, they'll usually be either near the top or towards the right side. Okay, and so here we have an example of an oxygen atom. We can tell it's oxygen because there's 1, 2, 3, 4, 5, 6, 7, 8 protons, and oxygen is atomic number 8 on the periodic table. And so remember that these nonmetals, they will usually gain, so here this oxygen gained 1, 2 valence electrons, and that's so that they can have a full valence shell, right? So we can see here that this orbital is full of electrons. And because they're gaining electrons, right, and so this atom has more electrons than protons. It has 10 electrons, but only 8 protons. Because it has more electrons than protons, and electrons have a negative charge, nonmetals form negative ions. Okay, so now we're going to talk about bonding real quick. So what is bonding? Bonding is when 2 or more atoms trade or share electrons. They form a chemical bond and attach to one another. Right, so when you think about a bond, you want to think about like 2 things that are attached to one another or connected to one another. So an ionic bond is when a metal atom donates electrons to a nonmetal atom, and they form an ionic bond. So ionic bonding is always going to be one metal, well, at least one metal and at least one nonmetal, right? And the metal is always going to be donating electrons or giving electrons to the nonmetal. In covalent bonding, that's when 2 nonmetal atoms share their electrons. So there's no donating going on here. They just share the electrons. We'll talk more about that when we come to covalent bonding. We're going to do ionic bonding first. But first, we're going to just talk briefly about how you can recognize whether 2 atoms are going to form an ionic bond or a covalent bond. Okay, so let's go through a few examples. So the question asks, would the following compounds or molecules, and so some of these will be molecules, have ionic or covalent bonds? So we'll start off with NaF, sodium fluoride. And so we need to look up Na, sodium, and we need to look up F, fluorine, on the periodic table. So sodium is right here. This is clearly on the metal side. So we have one metal. Fluorine is here. This is clearly on the nonmetal side. So we have one metal and one nonmetal. Metal and nonmetal, that forms an ionic bond. So whenever you have one metal and one nonmetal, it'll always be ionic. Okay, let's do the next example. So now we have H2O, or water. The H is hydrogen, the O is oxygen, so we're going to look those up on the periodic table. So here we have a hydrogen atom, or a hydrogen on the periodic table. Here we have oxygen on the periodic table. And those are clearly both nonmetals. So hydrogen's a nonmetal, oxygen's a nonmetal. And so when you have 2 nonmetals, we call that covalent. So, quick review. Sodium was a metal, fluorine was a nonmetal. When you have a metal and a nonmetal, it forms an ionic bond. hydrogen was a nonmetal, oxygen was a nonmetal, so this forms a covalent bond. Okay, so next up, let's do N2. Now, first thing I want you to notice about this is that this is not a compound. Remember, a compound is when you have at least two different elements in the same molecule, right? So here, hydrogen and oxygen are different elements. Sodium and fluorine are different elements. In this compound, we just have two nitrogen in this molecule, we just have two nitrogen atoms bonded to each other. So this is a molecule because the atoms are the same atom or the same element. Okay, but since nitrogen is a nonmetal, right, we can see it right here on the periodic table. That lets us know that it's a covalent bond because it's one nonmetal bonded to another nonmetal. Okay, next let's go over here. We have magnesium oxide, MgO. So we're going to look up Mg and O on the periodic table. Mg is right here, clearly a metal. Right, Mg. O is right here. We already said that that's a nonmetal. Metal and a nonmetal forms an ionic bond. So hopefully you're getting the pattern at this point. If it's a metal and a nonmetal, it's ionic. If it's a nonmetal and a nonmetal, it's covalent. Okay, so let's quickly go through the rest of these. Next up is beryllium chloride, or BeCl. Beryllium is right here. So that's a metal. Chlorine is right here. That's a nonmetal. Metal and nonmetal, it's an ionic bond. So just like sodium fluoride or magnesium oxide. Okay, next up we have phosphorus tetrahydride. So let's take a look for that one. Phosphorus is right here, definitely a nonmetal. Hydrogen is right here, also definitely a nonmetal. Nonmetal and nonmetal will form a covalent bond. So just like water and just like nitrogen. Okay, next up we have aluminum sulfide. So let's take a look for aluminum and sulfur. Aluminum is right here. Now this one might be a little bit trickier for you to tell, but since it's down and to the left of that line, it has to be a metal. So aluminum is a metal. Sulfur is a nonmetal because it's to the right of the line, above this line. So sulfur is a nonmetal. So we have one metal, one nonmetal. That means it's ionic. Okay, and then last up is cyanide, CN. So let's take a look for carbon and nitrogen. Carbon is right here. It's definitely a nonmetal. Nitrogen is right here. Also definitely a nonmetal. Two nonmetals form a covalent bond. Okay, and so then I just have 8 practice problems. I want you to go through and label these as either ionic or covalent. Let me know if you have any questions. I'm here to support you. Okay, thanks.